So this is order of operations. You've probably heard PEMDAS a million times. I'm actually going to use, for the first time, something called GEMS. I've never heard it before, but when I saw it, I thought that it may help to eliminate some of the common mistakes that I see being made by students. So I thought that it was worthwhile. Again, this is just a refresher. You hopefully know order of operations, and we'll see how much you remember from PEMDAS. So PEMDAS, of course, is really written in 4 lines, which is why GEMS is really great, because it just has the 4 letters. But PEMDAS, you have your parentheses, exponents, multiplication and division, which is supposed to be done left to right, and addition and subtraction, which is supposed to be done left to right. What students will often do is they'll say, well, the M comes before D, so I have to do all the multiplication before I do the division. And that's not true, because you want to move left to right. So that's why I think GEMS is kind of helpful. So I just want to show you what GEMS means, and maybe this will be the thing that kind of helps you. So the G is for any grouping symbols. And that I really like about GEMS as well, because it's not just parentheses. It's parentheses, it's absolute value bars, it's a square root symbol, it's a division bar. So it kind of includes that division bar in there, which is where students often struggle as well. Any kind of brackets at all, so any type of grouping, not just the parentheses, but a square bracket counts. So that's why I kind of like the G as opposed to the P, because it seems more inclusive. Of course, your E is for exponents. And then I like the fact that it only has the 2 letters remaining, because this will help you to remember that it's left to right. Because essentially what it's saying is you're multiplying. Division is the same as multiplying, right? If I divide by 2, that's the same as multiplying by 1/2. So I shouldn't really be thinking about multiplication and division as 2 different things. So if I just write it with an M, and again, that includes division, but if I almost see that as one entity, then I will probably be more likely to just work left to right. Same thing with just using the S as opposed to the A and the S. This would be subtraction, right? But really addition as well. And again, that'll help you to remember left to right. Addition and subtraction really are the same operation, right? If I'm adding a negative, I'm subtracting. So why am I thinking about them as if they're 2 separate things? And we'll sort of see that as we move through the problems. If you feel comfortable with PEMDAS, if you feel like I just completely confused you, forget I ever said GEMS, right? Don't worry about it at all. But if you're feeling like this was always something that you kind of struggled with, or not that you know that you struggle with the concept, but you found yourself making a lot of mistakes, maybe those quiz grades weren't what you thought they would be when you were assessed on this content, maybe this is the time to try to see if something new works, right? So before we actually go through and do some problems, I am going to do some problems with you. I just wanted to make sure we understood exponents, and I have 2 really good examples for you to clarify something, an ongoing theme we will see throughout the year. Exponents imply repeated multiplication, which is something I think I discussed in a previous video. But essentially, if I want to expand this, and that's a word we will use when we talk about exponents throughout the year. If I want to expand 5 squared, it's 5 times 5, right? The exponent indicates how many times I'm multiplying that number. So 5 times 5 is 25. 5 squared is 25. If I have a negative, and that's where these 2 examples are very different. Well, what's different between these 2 examples, right? There's only one thing that changes from here to here, is the removal of the parentheses. So obviously those parentheses are a key factor, right? Essentially, what you want to think about in these two separate examples is what is being raised to the fourth power, right? We say exponents imply repeated multiplication. So what is being raised to the fourth power, that's what I'm going to repeat 4 times. So when I see parentheses and that exponent is outside those parentheses, it's saying everything in those parentheses is getting multiplied 4 times. So I have -2 times -2 times -2 times -2. That entire set of parentheses is getting multiplied 4 times. So when I do that, right, -2 times -2 gives me a +4. Again, -2 times -2, +4. So I see that my answer is 16. Notice it's positive. If you take something like -2 to the fourth, notice I didn't say parentheses. If there are no parentheses around that negative, then the 2 is the only thing that is being repeated 4 times. This is essentially -1 times 2 to the fourth. It's not -2 to the fourth in parentheses saying multiply that -2 4 times. That's not what it is. This is, here's a negative and then here's 2 to the fourth. So the 2 to the fourth, that 2 positive is the only thing that's being repeated 4 times. And then there just happens to be a negative out in front. So when I do 2 times 2 times 2 times 2, I get 16, but because I have that negative, my result is a -16. Please just take a minute to think about the difference in the way the original problem looked and the way that answer looked. If you have the parentheses, it's going to make it positive. If you don't have the parentheses, it's going to keep it negative. But here's where we can kind of throw a wrench in that. If you take an odd exponent, like to the third, guess what? They're both negative. Because even when I expand this one, where the negative comes along for the ride every time, I have an odd number of negatives. So I'll get these 2 negatives canceling out. I'll get a +4, but times -2, so I get -8. And here, I'm going to get -1 times my 2 times 2 times 2. I still get -8. So just something to sort of think about. When you have that odd exponent, it's negative regardless of the parentheses. But with that even exponent, you want to be cautious. Think about that concept. Is that negative also being repeated? That's what you want to think about. And if you're just trying to memorize, this is something you're going to forget 4 months from now, right? Okay, when there are parentheses, it's positive. When there are no parentheses, that's going to be gone tomorrow, right? Or next week or next month. But if I understand that exponents being repeated multiplication, what is repeating, and that's going to get me my answer. Boom, I'll remember it for the rest of my life. I'll be 90 years old and I'll remember how to do that problem. I also want to show you how to do those on the calculator. And this is where students will often struggle as well, because again, you guys think the calculator either has a brain or has eyeballs and can see the paper, and it has neither one of those things. So you want to make sure that you are properly translating the information into the calculator. Otherwise, it's a waste of everybody's time. So just to show you, if I want to do 5 squared, I hit my 5. Now there is a little squared button over here on the left, but it's only a squared button. So if I had to do to the 3rd, to the 4th, to the 5th, to the 6th, and so on, I can't use that button anymore. So you should probably get comfortable with the caret, right? You know the caret from English class. You use that when you want to make an edit and insert something, right? So you have this caret right above the division symbol. That caret will give you your exponent, and then you type in 2 for 5 squared. It gives me 25. Notice when I type in these two, and again, make sure you're hitting your negative, which is down by your decimal point, not your minus sign. When I when I raise -2 to the 4th in parentheses versus when I raise it to the 4th without parentheses. You can see that difference, a +16 versus a -16. Here's where students often make, I've seen this mistake a million times. They get this problem on their quiz and they go -2 to the 4th. I'm not typing in those parentheses. Nobody's got time for that. Well, unfortunately, you also have a wrong answer. So you want to make sure the calculator doesn't know what the problem was supposed to look like, only you do. So make sure you're typing those in correctly. The calculator does PEMDAS, but again, that's assuming that you have typed everything in properly. And that's where students struggle. Well, I thought if I typed it in the calculator, it'd give me the right answer. Only if you type it in exactly as it appeared. So I have a couple for us to do, just 6, so that you can get a little bit of a taste of the different styles. And again, you have some practice that you can be working on in class this week as well. So again, just to kind of go through, I'm going to use that GEMS just to try it out. It's also shorter, so I feel like it'll feel like less. So first thing is G, any grouping symbols. So I see parentheses, those are grouping symbols. That means I need to complete what's inside the parentheses first. So 6 minus 2 is 4. I'm going to keep those parentheses on there just to help me out in case there's that exponent and I'm supposed to square something and it's negative and now it becomes positive. So I don't want to get rid of them just yet. But now that I see I have 4 to the 3rd, and maybe I don't know that off the top of my head. Again, it's repeated multiplication. So you should be able to think about 4 times 4 and then times 4 again. But just to practice with that caret action. So I have 4 caret 3 and my calculator tells me it's 64. So then I have 64 divided by 2, 32. So notice, first thing I did, parentheses, grouping symbol. Next thing I did, E, exponents. Third thing I did, multiplication, which was really in the form of division. But I'm kind of seeing those, this is the same thing. Once I did that, I had a single number. I don't have any adding or subtracting to do. If you look at number 2, and again, this is why I kind of like GEMS, G is grouping symbols, which it uses to include that division bar. Because when you have a division bar, it's essentially like you have parentheses around everything in the numerator and then everything in the denominator. So what that tells me is before I actually divide, I have to do those grouping symbols. So I need to completely simplify my numerator, completely simplify my denominator before I move on. And when I'm inside that numerator, it's like a new GEMS has started. So I'm hitting those exponents, then those multiplication and divisions, then those subtractions and additions. So I'm up in my numerator, right? I'm up in that top set of parentheses, and I'm doing 2 to the 4th first because I do exponents before I do subtraction. So I get 16 minus 1. There's really nothing to do in that denominator, so that denominator is going to come along for the ride until I'm ready to match it up with my numerator. Nothing bothers me more than numerators and denominators floating about as if independent from one another, so you need to make sure that those fractions stay as fractions. You can't just simplify a numerator and later on simplify a denominator and expect to get the right answer. It's just not going to happen. So again, you want to make sure you're realizing in that GEMS, in that G, is grouping symbols, which does include that numerator as its own piece. Because that fraction bar, that division bar, counts as a grouping symbol. It's grouping everything in the numerator together and everything in the denominator then together. So I have to do my 16 minus 1, then I'll do my division. And that confuses students, right? Because they say, but wait a second, you told me to do multiplication and division before subtraction. I'm not doing subtraction before multiplication and division. I'm doing G before everything else. So simplifying up that numerator is doing the G in your GEMS, your grouping symbols. Now all I have left is division, so my answer is 3. I just want to show you if you wanted to type this one in, and again, you have to type in parentheses in your numerator, which they aren't in the original problem. So you have to know that that division bar means it's grouped. If you don't know that, you're going to get the wrong answer. So I type in a parenthesis, 2 caret 4. Just be careful on the newer calculators. If you do the caret, it keeps you up in the exponent until you toggle out. So you want to hit that right arrow to get out of the exponent. -1, close my parentheses. My entire numerator is in parentheses. Divided by 5. And I get 3, which is exactly what I got by hand. So I'm going to go through the next couple a little faster for you. So scan through any grouping symbols, any parentheses, giant fraction bars, absolute value, square root. I don't see any of it. So I move on to E. Do I see exponents? Yes. So again, this one's tricky, but that's not a -4 squared. It's -4 squared. So the 5's going to come down the same times 7. The minus sign's going to come down because the only thing being squared is my 4, which becomes 16. So I did the E, I did the exponent, and everything else came down exactly as it appears. I don't just have a random 16 somewhere. Okay, that's how you get wrong answers. Now I think about, okay, do I have grouping symbols? No. Do I have exponents? No. Multiplication. Move through the entire line left to right and do anything that resembles multiplication or division. So I have 5 times 7, which is 35. Minus sign, so that's just going to come down. 16 divided by 2, that's like multiplication. It's division, and that's 8. I did all of it in the same line, left to right. Now I have my S for gems for subtraction. 35 minus 8 gives me 27. If you type that into the calculator, 5 times 7 minus 4 squared, toggle out of that exponent, divided by 2, you get 27. The calculator knows to do PEMDAS or to do GEMS, but you just want to make sure that you're typing things in properly. So just be careful here. We haven't talked about absolute value yet, but absolute value we'll talk about it as we move through the year, but it makes everything positive that's inside of it. The biggest thing I want to comment on absolute value, they are not parentheses in the sense that you can distribute. So students will often try to distribute into absolute value bars. It's a big no-no. So that's part of the G. That's part of those grouping symbols. So I'm going to do this first. Everything else is going to come down exactly as it appears. And instead of absolute value of -3, what do I make it? A +3. All it means is make it positive. If it's already positive, keep it positive. Now, do I have any grouping symbols? No. Any exponents? No. Any multiplication? Yes. I do 4 times -7, which is -28. Copy my +3. Do I have any grouping symbols? No. Exponents? No. Multiplication? No. Subtraction? Yes. -25. Remember, 28 and 3 different signs. So I do 28 minus 3 gives me 25. 28 was bigger and it's negative, so my answer is negative. And I have 2 for you that have giant fractions. So again, recognizing that there are in fact grouping symbols there, even though you wouldn't think about it that way. So what I want to do is I want to complete everything up top and then everything down below, and then I can do that division. So I have multiplication up top. I have to do that first. So -6 plus 2 times 5 is 10 minus 8. You can't do -6 plus 2. You can't do it. And then -8. You can't do 5 minus 8. Okay? So that's what I have up top. I'm going to, on the bottom, I'm going to do my division. -16 divided by 2 is -8 minus 4. I still have the giant fraction bar. I'm still working to simple up my numerator, simplify my denominators. So subtraction across. -6 plus 10 will give me a +4. -8 will give me a -4. And then on the bottom, -8 minus 4, both negative, gives me a -12. Now that I have one thing up top, one thing down below, I can go ahead and do my division. I have a negative over a negative becomes positive, and here's where I want you to be careful. The answer is not 3. Students often look at this and they say, it's 3. Yes, 12 divided by 4 is 3, but 4 divided by 12 is 1/3. So make sure you're paying attention. Wherever that bigger number is, that's where that 3 has to go in your result. And I have another one for you, which has some absolute value in it. I have grouping symbols up top, so I need to do those first. So 3 times 5, 15. 20 divided by 4, 5. On the bottom, I have grouping symbols. I have exponents. 2 to the 5th is 32. Now that minus sign is outside the absolute value bars. So the absolute value of 17 is 17, but there's still a minus out in front. Doesn't get rid of things outside the bars, right? So if it's what's inside's already positive, just leave it positive. So I'm simplifying this up. If I need my calculator for help, numbers starting to get a little bigger. Okay, maybe I need my calculator. And now I can do that division. Again, if I type this in from the start, I should get 5 as my answer. But you want to be careful. You need to have parentheses around your entire numerator and entire denominator. So you'd actually have to do parentheses, 3 times 5, parentheses, 20 divided by 4. Close those parentheses because that's my whole numerator. Divide it by parentheses, which aren't written on my paper, but I have to know they're there. 2 to the 5th, toggle out of that exponent, minus, maybe this part, I'm like, I'm not going to type in absolute value of 17. I know it's 17, and I get 5. Okay? A lot of people are confused when you see this, when you see the -6. This is the one, it's, on Facebook all over the place. And it's like 75% of people get this wrong. Why can't I just do -6 plus 2? And the idea is that multiplication does not separate terms. 2 times 5 is one item. It's 10. So it has to be treated as one item. So in that sense, I can't do -6 plus 2 because it's not a 2. It's 2 times 5, which is 10. So just try to keep that in mind. Pluses and minuses separate terms. Multiplication doesn't. So when your aunt argues with you on Facebook about whether the answer is correct, that's what you say. You say because multiplication doesn't separate terms. She's going to love it.